Okay. So today is a hard one, and I didn't want to start the stream too early since I didn't know not I would be spending hours doing nothing. As much as I care or don't care about that, but so I did read over this and do some prior thoughts. Okay, so let's just go over the basics here. Maximum number of events that can be attended, part two. I think part one was yesterday, something like that. You're given an array of events. You have a start, an end, and a value for the event, inclusive. Um, and then you're given an integer k that represents the maximum number of events you can attend. You can only attend one event at a time, so if something occurs on like day 2, then if you attend that event, then you can't attend anything else that occurs um, on day 2, inclusive to the range of that event. You choose the 10 event, you have to attend all of it, and you get the value. Turn the maximum sum of events maximum sum of values you can get by attending up to k events. So here, like if you have 4, 3, and 1 is kind of occurring, overlapping with the 4 and 3, then and k is 2, then you want to attend 4 and 3, obviously. So you get a maximum value of 7. Here, 4 and 3 are there again, but the kind of overlapping event has a value 10, so you want to do the 10 event, even if you can technically attend one more event. There's nothing available anyways. And here there's 4 events, 1, 2, 3, 4 occurring on singularly 1, 2 on the first, second, third, fourth day. If you attend 3 events, then you will get the values 2, 3, 4 for going in those days. So going over some thought process, given the size, the number of events, which is 10 to the 6, 10 to the 6 events dot length times k. Yeah, roughly 10 to the 6. I guess k of 1 is 10 to the 6. 10 to the 5, no, 10 to the 6 divided by 2 is 5 times 10 to the 5th. Anyways, dynamic programming is just too slow, I think, given that size. Backtracking, which is even slower than dynamic programming, is too slow. I was initially thinking binary sort or heap. Obviously, it makes a lot of sense to either sort the events array by either the start date or the value of events. I was thinking like maybe iterating over the highest value events and picking the k. Obviously, there's going to be big concerns about that, otherwise it wouldn't be a hard problem. Or part of the reason why it's hard is because there's going to be a lot of concerns. If you just try to pick the biggest k value things, then there could be overlapping events that make that impossible. Generally, when you have something where you choose it and it affects other possibilities, that's like, you know, backtracking type of difficulty. Long events can use up time, such that less than k events are attended. So in theory, you could have like I guess this is not any different than overlapping events, because long events that use up more time only affect it if it overlaps other events that would make use of that time. So maybe this is redundant actually. Obviously the greedy approach doesn't always work. Yeah, just like here, if you do here, the greedy approach would work, but here the greedy approach, actually here the greedy approach does work as well. But if you had a greedy approach where you had 10 and the next events were 6 and 6, and they overlap with the 10, then if you just pick the 10 immediately, then you can get the 6 and 6. And then I was thinking, what things could I do to simplify the problem? And one thing was pruning it. So if there's an event that is strictly earlier or strictly higher valued, but also strictly smaller within the time frame of another event. Let's say like within the time frame of the 10 event, there's just a single day event that was on day 2 that was 5 value. No, sorry. Let me think about it again. So let's say there was an event across all 4 days that was valued 5. Then the 10 value event that is in a smaller time frame, like a subset of the time frame of the bigger event, but also bigger valued, is strictly better. So you can prune out like an all 4 days, 5 or less than 10 point event. I actually tried thinking about how to prune it, and it doesn't actually. When I was trying to write the basic for loop to try to prune it, it didn't actually come out easily. Like it's might be a hard problem in and of itself to try to prune the strictly inferior events. It might be like n-squared comparisons necessary to see if like there's overlap and see which events are worse, which events are overlapping, which ones are worse. So I quickly tried. Yeah, that didn't pan out. Anyways, the one that I ended up thinking about was, and the more I thought about it, the more I think it might work. It's this binary search for the maximum sum. So if you can somehow, so in general, if you do binary search as a technique, okay, so binary search for the maximum sum is like basically guess the best possible and check, and then if it works, then guess higher. If it doesn't, then guess lower, and then eventually, find the best possible sum. So it's like a hot cold. If you guess that you can get 100 value from the density you tend, then you try to get like 200 value or something higher, and then let's say you didn't get 200, so you guess 150 to somewhere in the middle. I actually don't know if that works now that I think about it. It kind of worked in my head. Yeah. If you just attended maybe 2 events, maybe it would work. Okay, so anyways, how would it work? So if you if k is 2 here, if you can at any point determine what the maximum value that you can get up to that point, if you can determine the maximum value that you can get up to that point, that should be doable, no? So the main thing for binary search would be for binary search, need to have a single pass check, which is a method where given some guess value, value, return true or false. We return whether that value can be obtained by attending up to k events in, and this is important, in a linear pass of the events. So you can't do something too slow. I mean, you could do something where it's somewhat slow. Maybe it can do it in linear or n log n pass with time complexity n log n. So in general, it's going to be like you go through all your events in one go in like one for loop, and somehow you can check, if 5,000 was something that you can obtain within k events in that pass. You can't do it slower than that, or much slower than that. You can't do it obviously can't do it in So how to do that though? So if I have k equals 2, and if I can do it in one pass, actually I was thinking like summing the best possible points you can get given a certain split. That would just mean k equals 2. Like you can try to think about day 2 as being where you split your overall events by, and so you add the best value you can get before day 2 and the best value you can get after day 2. It ends up being 4 and 3, and so that ends up being 7, or the best value you can get before day 1, after day 1, before day 2, after day 2, before day 3, after day 3. And before day 1, after day 1 would be like 0, 3. Before day 2, after day 2 would be 4, 3. Before day 3, after day 3 would be 10, 10, 0. Before day 4 and after day 4 would be like, wouldn't that be just that would be kind of the, I wonder, can I do dp k times the events dot length? So the events dot length is 10 to the 5th. What is 10 to the 6th divided by 2? Actually, maybe this is doable with dp. The length times k. Actually, maybe this does mean that I can do dp. dp maybe has 10 to the 6 as its total operations or time complexity. O 10 to the 6. Or O of n squared, where n squared is basically k times times the length of the thing. Because if I were to say that for a given, like I'm thinking about here is for, let's say, k values, let's say k is 4, 3, 2, 1, 0, and the days are the horizontal, d1, d2, d3, d4. Then what if I said that, what if I went through the events array and I kept track of, in a DP matrix, the value at cell say kx and day y is the maximum value that can be obtained, by that day, by day dy, having used kx events. Maybe I can do that. So I would be, how do the events work in that sense? So I'd be filling in, I would be filling in this matrix using what technique? I would be filling it in with, say, I would assume that if I use 0 events, then this would be day 0. Then obviously it would start with 0 for everything here. And maybe everything else is like negative infinity, just have a very low value to do like a max calculation from. But actually, it should probably be able to start with zeros for everything for each day and each number of events picked. You're initially saying that you can get 0. So sure, you can set these to 0. And I think if you go through each event, and if you go through each event and you modified, what would you do? Maybe the DP matrix suggests go through each event. So let's say the first event was each sorted event. So first event was day 1, and set day 1 is the value of 1. So you can change day 1 event to 1. So you're starting with 0 event, you add 1 to it, and you get 1 event. And you get 1 event. and yeah, you get one event where you get one value by the end of day 1. So maybe there should be, okay, I think maybe I have this offset by incorrect. So on day 0, so something like that. So day 0, you for any number of events that you had, and this is going to take this value here, 0, 0 for day 0, and add 1 to it for day 1. And then in theory, you would also add it for day, maybe here is 1 and this is 1 is 2. I guess maybe it doesn't really matter. I don't think it matters actually. But for consistency, you probably would do that. You look at the DP matrix for everything up to day 2, which is day 1, and you would you'd say that if you go diagonally from there, going from k equals 0 to k equals 1, and you chose that as your only event, then it would be something like 2 is here, 3 is here, 3 is here. And this event would be taking everything up to day 2. If that's your first event that you did, then that's 3 points. If that's the second event that you did, then that'd be like 5 points, 6 points. And then here, if on day 4, this is the first event that you did, then that's 4, 7, 9. Technically, if your k was 3, like in the example, then you just wouldn't have a k equals 4. I guess that actually works. DP might work. Huh, interesting. Misjudged it. Okay. So what is the speed of this though? What is the speed of this? It would need to iterate over, well, it would iterate over the events. Alright, well. Ooh, yeah, I can't just iterate over, am I iterating over the days? The start and days is just not possible to be iterated over. Yeah, okay. I guess the issue might be that I need to skip over days. Yeah, I need to skip over days. By which I mean I can't have a for loop that goes over each day and then the for loop needs to go over every event. So for instance, what happens if my thing was something like this? Let's say my events were 1, 2, 1, and let's say it's 5, 6, 1, 10, 11, 1. So 1, 2, 1 would mean that I would look at the day before, which is day 0, and then I would increment. Yeah. Okay, so in I should probably just do a different thing here. This is example 3. But if it was, let's say example where I have this, and I have k equals 3, then k is this axis, day 0, day 1, day 2, 3, 4. So it would be something where obviously it starts day 0 with 0. And then I'd say 1, 2, 1 means that I have something that starts with 1, starts at day 1, ends at day 2, gives me 1 point. So in theory, day 1, by the end of day 1, I didn't have anything that gave me any points. But by the end of day 2, if I did one event, then I could have gotten 1 point there. And maybe it fills out, and this is 1 as well. These are obvious always just 0. But now, I fill out this is 1, then in theory this should be 1 as well. Like this fills out this thing being 1s. But how do I track that? How would I track that? Because if I do the second event where I start with day 5, 6, and 1, that would mean that at the end of day 6, it should be 2 here, having done 2 events. But normally if I look at day 6, or if I look at the second event where it starts at day 5, then I would normally look at this spot right here in the matrix and somehow determine that spot should be a 1. That spot should be a 1. Given the fact that the 1 here kind of extends out to be 1 there. The issue is I can't really, given the size of the days could be 1 to 10 to the 9th. I can't just create a matrix that is that long, that has that many days and fill out all those spots. So it has to be kind of like a sparsely kept data where I have to fill in the holes. Or like something like this, right? If it's like 1 to 200 and it's 1 point, then in theory I'd look at day 0, add the values there to 1, and then change day 201 to say that the most I can get at that point is 1 point currently, having done that event. So if I kept track if I kept track of for each k number of points I can get up to day x with that k. Interesting. Also maybe do the reverse. Can I do the reverse? Or go by the end date instead of the start date? Only the same issue would crop up. So yeah, so something like this is the main issue, or this is one issue where sparsely filled out up to, and there's some gaps between one day and the next day. And then there's also the issue where it's just an event goes far into the future. So if I had a list for each k, K3, K2, K1, and I said K1 had 3, 1. By day 3 I can get 1 point. Or maybe I get something like 3, 1, 201, 1. Get day 3, get 1 point. Day 201, get a point. In theory, this is a strictly worse event to attend than this one. So I should also be able to crop this or prune that if I could somehow detect that. It's 1. So 1 event attended. By day 3 I get 1 point. By day 2 I have a point. But like it could be something where it's not. Maybe this is 10 points. So therefore it's not strictly worse. And then how would I insert this information within it? So day 5. Okay, so if I iterate over the starting day, so I have an event sorted by day, by start date. If I iterate over the starting days, so because the starting day here was 1 and 1, I didn't have to worry about kind of conflicts because it's not going to affect each other. I don't think. Like you can't go to both, given that they both start on the same day. So for a given start date, I would process all the events for that start date simultaneously. But then now the day moves to day 5, and what do I do with day 5? In theory, I would do something where I would need to add another possible thing here. This is the first event I attend, then it'd be by day 7 I get 1 point. guess maybe it's possible that I maintain a sorted array. Oh my god, that'd be kind of brutal. Is it possible that I maintain a sorted array? Yeah, so this is, say this is 10, because then, so this would to be here. Interesting. I should know that at this point this is strictly worse. Like attending one event by the 7th day. Probably wanted, I could have gotten that one event over with by day 3 using the first event rather than day 6 or day 7, because the points are the same. So in theory this array for having attended one event should be increasing on the day and increasing on the value, because anything that isn't like that would be strictly worse in some way, or would have some strictly worse event attended, or having, like, it wouldn't make sense for me to say that by 201 I can get day 10 or 10 points, and by 250 I get like 5 points, right? That wouldn't make sense for me to go on a later day with a lower value, or a later day with the same value. But if it's a later day and a later value, then maybe that makes sense as my first event. So this 2 has to be, the value of this kind of in-between event has to be bigger than the value before it. Strictly bigger. And if it should be smaller than the values after, and then the value after it. If it's not, then I can maybe, like if this is worth 20, then I should be able to just remove these. Remove the later events. So it's kind of like an insertion, possible insertion. Yeah. Interesting. And then if it's not an insertion, then what? So now if I have k equals 2, I have 2 events, and then I should be able to say that where this was inserted here, the best I can do before that day should add with this event. So if I can get to before day 5 with basically 1 point, then I can get to then I can get to this thing with 2 points, so it'd be like 7, 2. No, 7, 3. In theory, if I had processed the first two, I should have also had 201 with 11 points. No, sorry. They were mutually exclusive, so I couldn't do that. Or I guess 201. No. By going over the vents. Yeah, I think this is only one, right? 7 starts after 3, but not after 201. Okay, and then if I do the next event being processed, I think I go top down first. So k equals 2. See where 10 would be inserted. 10 would be inserted after the 7. And so it would be, this would be 12, an extra point, so it would be 4. 12 being the day after 11. And then k equals 2, 10 would be inserted here. So that means that I could do 7, 2 plus another 10. 7, 2 plus another 10. It would be 12, 3. So the best I can do by day. No, that's not right. 7, 3. No, that is right, that is right. So by day 12, if I'm trying to use this on top of this, then it'd be 12, 3. Then I could say that because this is strictly worse than this, where this is using these two events, or using those two events as it being intended, then I should probably just not worry about that. So for each by the start date or the end date. If I go by the start date, then it has to be the start date, right? I have to sort by start date and worry about the end dates later on. Maybe. If I could only just make these things have no insertion, or kept track of insertions later on, that would be ideal. Since I don't, in that case, I could maybe just have it append onto the list rather than figure out where it would fall into the list. So 1, 2, 1. And that gives me day 3, 1.1, 210 gives me day 201 points. And then insert, gosh dang it, insert 7, 2. into this list. Insertion just flows. I guess inserting it is not, in theory, that much slower than just another sort. How often do I have to do that? I 1, 2, 1, 2, 1, 1, 210 on day 1. And then I would be on day 2. I had like a separate heap. What if I had a heap of everything that is past this? Like what if I had a heap where it's like 201.10? Actually, what if I had a heap where it's like everything that would be any day afterwards, right? So initially on day 1. Day 1, there's nothing in K1 I have to worry about. And I would add 3, 1, and 201.10 to the heap. 3, 1, and 201.10 to the heap. Yeah. And then the next thing I would do is I would move on to the next events day, which is day 5. And then I would say that I would pull everything from the heap that was before day 5. So 3, 1. And in theory, if there was something that was worse, let's say I have a 1, 2, 1 and a 1, 3, 1. Thus my heap actually has like a 4, 1 here. Then when I pull from the heap, I pull the 3, 1, and then I pull the 4, 1, but if the 4, 1 is actually worse than the 3, 1 because it's a later day with the same value or lesser value, then I just don't add it to the DP kind of list. So it's only 3, 1 that's a concern. So now I consider how I can actually, how this event would affect it. So if it's 3, 1, then that means I end day 3 with 1, or start day 3 with a point. So I could have start day 7 with 3 points, 2 plus 1, or start day 7 with 2 points. No, add that to the heap. 7, 2. So I have heaps and lists. Interesting. So I would have a heap here as well. Actually, yeah, so this is 7, 3 would actually be on this heap. and then do the next event, and the next event is going to be 10, so day 10. So that means I pull everything off the heap from each of the lists, each of the levels that is before day 10. So this moves to the 7-3 here, and it moves to 7-2 here. And now it considers what would happen if I have day 10. So this means that if I do those 3 events, the 1, 2, 1, 5, 6, 2. 5, 6, 2, the 10, 11, 1. Then by day 12, if I did it with 7-3, then it'd be 12, 12, 4. I can get by day 12 4 points. And then 10, 12. So this thing would work with this thing clearly. So this would be 3 points. But 3 points by day 12 is not strictly better than this. So it doesn't add anything to that heap. And then this thing does work. I wonder if I should just not worry about strictly worse or better until I pull it off the heap. Yeah, maybe I don't really worry too much about that. Maybe I just do 12, 4, and then 7, and then 12, 3 here. So adding this event to this event is 12, 4. Adding this event to this event is 12, 3. And then add myself to this thing, so it'd be 12, 1. And then did the next event. So there's like a 11, 15, 5. So the next day it'd be 11. 11 is yeah, I think that's right. 11, 15, 5. So it'd be 11 is after this thing. So it would add on to this thing 16, 5.8. 11 is after this thing, so it would add on to this thing 16, 7, and then it would just insert 16, 5. And then maybe if I did something better, the start date was, let's say 13, 13, 13. Then I would pull off the heap. Well, I would pull off the heap 12, 3, but I would only append it onto the stack if the value when it's pulled off is actually bigger than the last value up to now. Actually, I don't need to know the 3-1, do I? I just need to know the biggest value up to now for that k, where I know what now is. So for instance, I know up to now, where now is day 13, that I can get 3, and I can get 2. You need to know the day here, day and values. Interesting. Okay, let's try that one more time. So for each k, for each number of events that I've done, I keep track of k0 is always 0. I keep track of how many points I can get. For a given day. So the day is 1. So that means that my heap will have 3, 1, 4, 1, 2, 1, 1, 2, 1, 10. Not really worrying about pruning it or anything like that. Even though 1, 2, 1, and 1, 3, 1 are, the 1, 3, 1 is strictly worse. So that's day 1. And now I move on to day 5. At that point, I take off the heap everything that is the day before 5, and I keep the largest value that I see. So that means I see 1. So I can get 1 point up to day 5. And then once I do that, I also add to the heap that current event. So by day 7 I can get 2. And then I extend that to the other heaps. So by day yeah. So by day 7 I can get 3 here. Okay. And then I do the next one, which is 10, 11, 1. So day is now 10. So I pull off the heap anything before day 10. So this means this thing pulls off the 7, 2, and this becomes 2. This pulls off the 7, 3, and this becomes 3. So by day 10, I'll add the 11, or by day 12 I can get 1 point. And I could do a prevention of adding this thing to the heap at all. If it's worse than this thing. No, okay. I don't know. Here, this would be by day, so by day 12, I can get 3 points. And by day 12, I can get, doing 3 events, 3 plus 1 is going to be 4. Having done 1, 2, 1, 5, 6, 2, 10, 12, 10, 11, 1. The next thing I do is day 11. 11, none of these things pull off the heap, so it stays the same. Then I'd add like 16, 6 to this heap, or 16, 5 to this heap. This would pull off 16, 5, so it'd be like 16, 8. And this would be 3 plus 5. No, sorry, this is 16 plus 2 plus 5 is 7. And then this would be 16, 8. That was day 11. Day 13. I'd pull off the heap anything before day 13, so pull this off. Doesn't affect anything. 12, 3 doesn't affect anything because 3 is already there. And then 12, 4 pulls off and this becomes 4. Okay. I think I've done enough of a mock algorithm of what I want to occur crossing the events. I think I know what this is how this algorithm should go. Okay, so I sort the events by their start date. I have a dp equals just the 0 times k, I guess maybe k plus 1 times k plus 1. Keep track of, actually let's say I have day 0. This is a dynamic program matrix, or this, and this will be dynamic programming algorithm for a given day. For a given day, the maximum value obtained using k events up to that day. For okay, and I need heaps. So I'll say future, and this would be a list of lists, list for k in range. Actually, can I just do list times k plus 1? No, I actually don't want list, right? I want heaps. Is that something I can do? Heap? I guess heap is actually a list. Alright. Oops. If I can start with list for actually list times k plus 1. It's going to give me the right thing. Let's say future of 0 dot append 1. I actually don't need k plus 2. This is not quite it. Yeah, I don't think I can multiply lists in this way. I think I need to be something that is list k in range k plus 1, or is it just k? Heap k, 0 k, 3 heaps. Go k in range I in range k. I think this is okay. I think that's what I want. K is 2. So future is max heaps with tuples of future days of day value where day is some future day and value is most value is max obtainable by that day. So this is just going to be for each number of events attended. Have heap of tuples tuples day comma value day is some future day and value is maximum. Okay. So for each event, maybe I can say start. If I need to go over the indices. Let's say, okay, J now. So day is day 1. For every start, end, and value in events, if the start is equal to the current day, then I just need to add those to the heaps. Because it's, yeah, I just need to add those to the heap because it means I haven't really moved days. If no movement, if no change in day, add its possibility to heaps. So yeah, so add its possibilities to the heap. So I think it would be something like for every, actually I don't even think it's 4, it's going to be just dp of 1, actually dp of 1, dp of 0, no, it's going to be future of 0 dot, so that's heap, heap push onto future 0 heap the tuple that is the end day plus 1, end day plus 1, and the value. Else, and then just continue. And that's the only thing I need to worry about. If it's just, I think that's the only thing I need to worry about. Haven't moved days. Is that true? Move days. So start with day 0. But I have to move day here, right? Make this into day. So I do day 1. I do this add to the heap, add to the heap, add to the heap. And then I do day 5. And when it changes the day from a different day to this day, yeah, I don't think I'd move days. Yeah, I don't move days, so I think I just can continue. So now, so it puts like day, puts onto the heap 2, 3, 2, 4, 2, or 3, 1, 4, 1, 200, 110, and then next time it does it, if the start is after this day, so start is after current day, transition days. So for every heap needs to pop. Take remove from heaps every feature that is now possible. So for every heap, while there is something on the heap, so future, and the end day of that heap, that feature is now, or day is some future end day. So end day is less than now, is less than start. So I guess I can say here day is the start. Is before the start. I guess it's less than or equal to, because I make this into non-inclusive. So less than or equal to current day. And then I can say we pop from feature I the whatever end day and value. I guess value, sorry. Future value. I guess it'd be best value feature value. I don't care about the end day, I just care about the feature value. If the feature value is, I need to change dp of I, dp of I plus 1. It's just dp of I. dp of I, so dp of 0. I wonder if I need to keep track of dp of 0 at all. It's always going to be 0. 0, 1. P of 0. So k is 3. K is maybe dp of I plus 1. Okay, dp of I plus 1 is equal to maximum of dp of I plus 1 and this feature value. And yeah, I think that's it. Doesn't quite feel. Okay, I think that's right. So change days, pop from the heap. If there is a feature and feature is before this day, take it, maximize the number of value I can get to now, and then and then what? Then I need to lost my train of thought. So I pop it off. Then I need to push onto the heap stuff that maybe include this event. Yeah. Stuff that maybe includes this event. So, and I can do maybe a quick check before I push onto heap stuff that includes this event. So for I in range k again, go over my dp. If dp of I plus the value from this current event is greater than dp of I plus 1, so if I can add this event to the number, the best I can get of one less event, if I can add this event's value to the value I can get for I events, and that value is bigger than I can get for the I currently know of for getting I plus 1 events, then I'll add it. So future of I. So if I have I 0, the best I can get for 0 plus this event is greater than the best I can get for 1. The future of 0, 0 is technically the first heap, which is what I want there. So future append the tuple that is the end day plus 1 and the value that is dp of I plus the value of this event. Okay, I think that's right. No, it's not append, it's a heap push. Oops. Oops. So heap push into the future I heap the tuple that is n plus 1 dp of I plus value. Okay, I think that's right. Now what happens at the end? What happens at the end would be I need to pop from my, actually I don't need to have done all the events, right? I just need to pop off the heaps, find the maximum value, and then find the maximum value of that. So for every heap for I in range k, dp of I equals max of dp of I. Actually, for every while there's something on the heap, I want to do dp of I, dp I plus 1, dp of I plus 1, I think. Is equal to maximum dp of I plus 1, and heap pop. So something future value, heap pop future of I, future value. Yeah. So I take everything off the heap, and then I can just say return the maximum in my dp array for any number of events that I can do. So future of I of 0. This is a heap. This is the first element of the heap, and then I need to say the day, which is the first element of that tuple. That's a lot of test cases. Let's see what's going on with this. One, three, four. Okay, so let's go ahead and just do a quick sanity check here. And print out my events in sorted order. So 1, 1, 4, 1. Okay. So I got 5. That should have been 9. Okay, so it should be something like, so case 3, 3, 2, 1, 0, and actually, so I think maybe I can do so here's my BP array, so K3, K2, K1, K0, 0, and my heap. So it starts with day 1, and these are all initially 0. So if I start with day 1, my heap is going to be, I can get to day 2 with 4 points. I can get to day 4 with 4 points. Okay, I think that's it. And then I start day 2. I can get to, so this would transition from day 1 to day 2, but nothing gets pulled off the heap because these things, I don't think this thing should get pulled off the heap, right? It has to be no, this thing does get pulled off the heap. So I could get to day 2 with 4 points here. Start, I remove it off the heap first. Yeah, I remove it off the heap first. And then I would do push onto the heap. Yeah, I would push onto the heap. So I push onto heap day 5. I can get 1 plus 4, which is 5. I pushed onto heap day 5. I can get 4, just 1 point, 1 plus 0. Now the next iteration, I'm still on day 2, but I should be modifying. Well, should I? I'm on day 2 still. Heap push, I see, yeah. So in theory I could have done day, when I took it off the heap, I'm adding stuff onto the heap. Yeah. I need to do multiple adds at once. Or multiple pushes off the heap at once. Because these things, transition days here, transition from day 1 to day 2, but then everything here, this day 2, should have done this action here. No change in day adds possibility to heaps. Yeah, it doesn't work. So I think the simplest thing is, if it's for any start day, the start equals day. It should just never be the same start day. So I think this is probably going to need and have index, and n is the length of events, while n is less than the number of events, or index is less than the number of events. Then I'll say start end val equals events at this index. And then I have to move days. Then I can say day is equal to start, and then do a while loop. Yeah, I do a while loop, and I do everything that happened at the start day. So while while index is less oh boy, index is less than n, and events at index equals start, while events at index at 0 equals start. Then I do index plus okay, I can say day equals day is whatever the first event's day is, while this is, oh, I shouldn't be modifying this in this way, or whatever. Well, index less than n, events at index of 0 equals day. Then I want to what do I want to do? Do I do a push? Do I do a pop? What do I want to do here? 2, 4, 2, 4, 2, 2, 5. I want to add it to each of these things and increment the index. So transition days, start is after current day. If no change in day, add its possibility to the heaps. So it's the first time I see this day. Start after current day. Transition days. Maybe I can do some sort of hack here, actually. So basically what I want is if the event is on a certain day, so it starts at day 2, and the next event that will be processed is also on that day, then I kind of don't want to I kind of want to transition to that day again. At it 1 to 2, 1 to 2 again. So I kind of want to do everything that I would on a transition day. Move remove from heaps every feature that's now possible, and then do this thing again. So maybe I can do something that's kind of hacky, but like index 0. Well, I can say here for while index is less than n, start n value is events at this index, and then do something like this. But I can then check if the next event, if the I normally would increment the index. I would normally increment the index every time. If the new index ends up this next index, start date it matches the current day, then I don't change the day and continue. Actually, if it doesn't have the same day, then continue. If start equals day, if no change in day, add its possibility to heap. Add this, add this, add this. Transition. I'm on day 5. In transition, I'm on day 5. Maybe I need to go back a day after I transition in case I do a repeat. Go back a day after I transition in case I do a repeat. Huh. Maybe that would work. So, no change in day, add its day to its possibilities. Otherwise, transition to the current day. And then I say day is actually start minus. So if I need to, I can transition again to the same day. So I'm going to slow it down. Is that going to be incorrect? That might be incorrect actually. So I transition from day 1 to day 2. I process everything from day 1. So now I think I'm day 2, then now I'm day 2. Now I go back to day 1. Actually, that's probably fine. That probably is fine. Yeah. Oh my god. Oh my. It's been so long since I really pushed myself on a hard. Oh my god. Okay. Well, yeah, that was that. Every time I do one of these, it's like always feels like I'm doing the hardest problem I've ever done in my life with no clue as to how to solve it. Yeah, like every single hard problem I do, it gives me no confidence that I can do another hard one. Oh, 2 hours. Interesting. I remember when I started this. 2 hours ago. 3 hours ago. Okay. In the end, the code doesn't look that bad, I guess. I have never seen, I don't recall using a heap slash a separate heap array in addition to a kind of normal DP matrix slash array before. Although it is interesting. It's interesting. Okay. So the summary here would be yeah, I totally blank out when I feel the joy of finishing one of these things. The summary here would be keep track of, okay, this is in general. This is dynamic programming approach, where you, for each number of events attended up to k, keep track of max value of attended events for some variable day. This will be, so the main thing is like the big concern is how to change days, how to kind of iterate for possible days. Not possible to go over each day one by one, as the range of start and end dates are too large. So like 10 with 1 to 10 to the 9th, which is too many days. So instead of a DP matrix with kind of dimensions of k value, so 0 to k, and day value and date, have a single DP list an array of heaps where heaps of I has tuples of day value of n day values for max value obtained attending I events by n day. So for example, let's say heap of 2 heap of 2 is equal to, say, 5, 100, 20, 120, and 80, 1,000. This would mean attending 3 events. Here the index is 0 is 1 event, index 1 is 2 events, index 2 is 3 events. Can get 100 val by day 5, 120 val by day 20, and 1,000 val by day 80. So that's the heaps that you want to have, and then the main loop would be, or the main things would be, create the DP list and heap arrays. We call the DP list DP, and the heap array future. And then to iterate over and variable and day variable. Well, the day variable is initially 1. Iterate over every event, where on iteration you're going to if the event is on the current day, push single tuple of doing that event onto heap 0. So basically treat this event as the starting event of all attended. No other event is attended by that day. So that was this thing right here. Treat event as only attended. So on your heap where you attend one event, you're going to say you attend this event, so the end day is going to be n plus 1, and then the value is whatever the value of this event is. And so that would mean that if you had a bunch of events that had a start day of day 1, like 121, 131, 210, then all these 3 events, they occurring on day 1, which is your initial day, they're all going to be pushed. So day 3 you have on that heap 1 point, day 4 on the heap 1 point, and day 201 on that heap 10 points. And then if event is after current day, then basically pretend transition from current to that start day, which is remove off each heap every off each tuples for where end day is before new start day. So there's this thing here. Transition, so for every heap, if there are future events on that heap and the future event has an end day before the current day, take that, basically kind of, well, now we can say that we've done this those events through those days, and then while removing it, while increasing max value while tracking max value attending k that number of events. So basically dp of I equals maximum dp of I and future value, right? And then part 2 is add onto heaps. This is what's this called? The recurrence function, the recurrence relation. This is kind of like the recurrence relationship. Relate dp of I to dp, or if event if event val plus dp of I is greater than dp of I plus 1, which is if attending current event with I, if attending current event, if current event val plus value of attending I events plus value of attending I events is better than current best val for attending I plus 1 events. Add this event to the heap. So like this thing right here. If possible to improve value of attending I+1 events. Add to and then note due to possibility of kind of repeated event starts, added day minus equals 1 after transition to repeat the above part B for future events on the for later events in array for same day, because you need to do that same sort of logic to see if those later events that have the same start day also could improve the DP list. And then lastly just after going through all events, remove all future events from heap, again maxing DP of I each time. What the hell? Maxing DP of I each time. And then we'll return the maximum of DP array, since it's possible that the best val is attending less than k events. So DP of like 0 is attending 1 event, DP of 1 is attending 2 events, DP of, I guess, k minus 1 is attending k events, but you didn't necessarily have to attend k events in order to get the maximum value, as in the example 2. Time complexity, this can be O of n log n to sort the array, and O of n log k, where k is the size of the heap. Actually, is it n log k? Whenever you do heap insertion is a log k cost. As when adding tuples to the heap, cost of adding, or time cost of adding, is log k for log k. Wait. I guess k is also the other thing, right? K is the number of things. So I'll say log p, where p is the size of the heap, and I guess this would be nk, the size of the number of events, times the number of, it's the number of events times the number of times the number of things, number of events times the number of events you contend. Yep. is log p, and you need to do log p for each event pretty much. Okay. Space complexity, this ends up being O of k. It's actually O of nk. Like everything could be on the heap. All the events could actually be on the heap at some point, in theory. Nk, since all events could be on the heaps, on each heap, really. Yeah, I guess that's why they actually had this kind of as a constraint that they gave you. Otherwise, if they said this was both like 10 to the 6, then it would be 10 to the 6 and 10 to the 6, which is a bit too big. Alrighty. Well, that was, I wouldn't say that was fun, but that was nice to be able to solve.